Yo, what's up? Good morning, good morning. Okay, so the optimism we ended on yesterday, yo, what's up, Derek, is still here. I think today is the day where we finally finish this shit. Or I'm pretty sure it is. And it's gonna look so much cleaner than this. So, let's take a quick look at what we have. And then I'm gonna explain the solution, and we can implement it, and we're gonna face no problems at all, and then we can move on to some other stuff. What's up, Cooler SK? So yes, yes, okay. So it's the seams. If we just interpolate points, so if we have two submeshes that meet and they don't have the same subdivision, then we update or interpolate the points that exist for one but not for the other. That way we align the different subquads. But that doesn't work with the rasterizer, because we can get some flickering, because we have two edges meet, it's one triangle edge on one side and two or more triangle edges on the other side. We get a little bit of a floating point rounding issue, and we get some flickering when we rasterize it. So we always need to make sure that we have the same points on neighboring quads, right? So what we're gonna do is that we're gonna constrain the tessellation a bit. It's not gonna be as dynamic as it is right here. We're gonna constrain it such that neighbors, the subdivision difference between neighbors is only ever just one. Right? So if this one is subdivided x times, let's see here. If this one is subdivided x times, these are subdivided x minus 1 time, and these are subdivided x minus 2 times. What's up, D3 guy? Thank you for the raid, appreciate it. Hope you had a wonderful stream. So that's the first constraint we're gonna add to this tessellation. If we do that, then shit, I love this document. It's very beautiful. If we constrain it like that, then we get something like this. So this will pretty much be the worst case we will need to handle. We just let it be like this and send it down to the geometry shader. And then in the geometry shader, for these 4 quads, we subdivide them like this. So for the one quad that is subdivided the most, we don't do anything. It's only ever, so if we find this edge and we find that the neighboring quad is subdivided more times, then we just add this tiny little point, and this one, of course. Because these points, they are already added by the final subdivision. So we just need to add this one, and it's gonna look beautiful. D3 just stopped by for a second, getting very tired. I know that. Raid and run. That's always how I do it. And I didn't have that much time thinking about this problem after the stream yesterday, but I can't see any downside with this. Like, this is beautiful. This is probably the most beautiful seams I've seen recently, just compared to whatever the fuck this is. Get the fuck out. But then again, if we would have had the same constraint here, we would just have this, which is kind of beautiful as well, but it doesn't give us this topology that I want and love so bad. Okay, so this is what we're gonna do. What a document. These are figures fit for a thesis, definitely. Okay, so the first thing we're gonna do is we're gonna constrain the tessellation. This is actually the smallest we can go. 6. No. 1 maybe. Oh, 10. Oh, fuck, it's gonna look beautiful, I reckon. Good morning, Harukanan. Fuck, I'm optimistic for the first time in a few weeks. And then we do the final split and it's gonna look beautiful even on the edges. Okay, great. Okay, so let's do the first constraint initially. So I'm gonna take... Let's take this one and bring it down. So the idea is that let's denote don't we have a camera icon? Misc Advanced. You probably do a basic camera. Okay, that's only a square. Do we have rectangle? Okay, this is our camera. It's beautiful. Can't I scale? Wish this one was over. Okay, beautiful camera. Look at the white stuff comes down like holy hell. 20 centimeters in an hour or so. What the hell? Is that the most snow you've had this winter season? I think it has been years for me since I saw that much snow. Okay. So, if we have the camera here, we subdivide this one x times, x minus 1 time, x minus 2 times. But what if the camera is here? We just need to define how we're gonna handle this. We're probably gonna do okay, we want to constrain the camera to... Come on. We want to constrain the camera to... any of these points. So what I'm getting at is that we're going to take the camera position, we're going to truncate it to one of these points. If it's truncated to here, and then we check, is the distance of this subquad to the camera less than a full step? If so, subdivide this one fully. And we're going to base it on how many steps this distance away it is from the camera. So if it were located here, we would subdivide this one the most, these one less. If it were positioned here, we would subdivide these the most, these one left, and yeah, that's it. That's beautiful. It's like we got the whole year's snow in an hour. I mean, it's pretty magical, but maybe not in the middle of March. Usually I would say better late than never, but not this time around. So, in our shader, first of all, I'm gonna clean up this shader a bit. I wonder... We have added a lot of shit in this one, haven't we? Actually, I don't want to commit this to my repository, but I'm gonna create a local duplicate. If this solution I'm so very optimistic about, if it turns out that that one too is shit, then we can go back to this one. So what is it? Environment shaders and terrain tessellation test. Just gonna do a local copy of that one. And then we do this. Remove this. Remove this. Geometry shader untouched. I don't care about this. Interpolated point. We can leave interpolated point for now. Lerp domain shader output. That one we want. So we don't care about. So everything we did yesterday, gone. Like now when I think about it, I don't think calculate distance between edge and point. I don't even think we need this one nor anything of this. So we're gonna do this and we're gonna do this. We can make it a little bit finer as well. Ooh. Okay, I fucked up. This. Inside. And all of this is just going to be equal to x. And now it's up to us to calculate x. And we don't need this one either. Don't think. No. Okay. I think we're gonna do... We already have position center VS, that's great. We're gonna start by doing... the distance, inverse lerp, something distance, bounds.x, tessellation distance, bounds.y, and length of view vector center vs. T distance, then we do how to round lerp zero tessellation max amount e distance, something like that. Undeclared identify, what do we call it then? Tessellation amount POW, that's not entirely true. Maybe it is. Okay, but I did it the other way around. We want to do tessellation amount power first and then 0. Okay, so this we recognize. This one we have seen multiple times before. It's just that if this value is low, we get 2 to 1, 4 to 1, and this is what we want to avoid. And so this one is tessellated x times, this one is tessellated x minus 1 times ish. And that's fine, that's the difference we want to see. But if we go from this one to this one, we have x, and here we have x minus 4 times or something like that, 2 times maybe. We just ever want to have a 1-step difference. So we need to truncate the camera position. We're gonna truncate it on, I'm not entirely sure. First of all, we're gonna start with just handling the X and Z position. We don't really care about the height. So that would mean that even though, so we're above this one and we zoom out, we ignore Y distance, or we are gonna ignore Y distance. So this one will still be fully tessellated. But that's just as a first step. We definitely need to take Y into account, because I'm probably never gonna support this type of camera angle in this game. I don't see how that... maybe actually. But I still want to take it into account. We still don't want to render the full terrain at full resolution. Okay, so we're gonna truncate position. We are gonna do... I want to be able to debug this, so what we're gonna do is we are gonna send down the camera. We are gonna render the pixels as a distance to camera position. And then we're just going to move around the camera and see what it truncates to. So once again, we want to be able to truncate to the corner vertices of the subquads. So corner vertices are these, but we also want to be able to truncate to center points of subquads. There might not be a vertex here, but whatever. So we need to figure out, we have the distance of the full terrain. We then want to figure out the distance we have here. We're going to do it in world space, and then we want to take half of that. So I don't think we have this information in the shader initially. We have dimension, mesh properties, dimension. We have max height, tessellation amount, pow, split quads. Yeah, we don't have it here, so we're gonna add mesh properties. I want to say resolution, mesh resolution. We're gonna do it as a vector. I don't have any ideas of supporting rectangular meshes, but you never know. It's not that big of a step to implement that as well, so whatever. Initially, we give this 1, 1, 0, 0. Okay, I want to do... Let's rename this one mesh dimension. And let's rename this one mesh resolution. To make it extra clear for future me, I could write mesh initial resolution here. But I don't think I want to do that. Let's try and keep it short. Our variable naming in shaders is already long enough. Mesh resolution. Okay, so the question is, so we have this full mesh. The initial mesh looks like this. We have subdivision of 2. So we create, yeah, the initial mesh is just this point and this point. Then we subdivide it once, we get this point. Then we subdivide it once more, we get this and this point. Subdivision 2. So we're just gonna do it like this. Let's exit. Edit script. And we have set texture, set vector, height map size. It could actually also be that we don't need to send in this one. We can only survive on set vector mesh solution. But we'll see. And do we have to send in a vector 4? Right. Vector 4.1. And then we want to multiply this one with something, and we want resolution. I think we're going to make resolution be the number of edges. Fuck yeah, we are. So our original mesh looks like this. We have a resolution of 4. And that's just... Is that just subdivision, or 2 to the power of subdivision? It works for this one. If we just had one subdivision, we would have 2. So we would have, yeah, this one and this one. If we subdivide once more, we get 2, 4... 8, 10, 2, 4, 6, 8, 8. So 2 to the power 3, that holds. So we can just do mathf pow 2 subdivision times this one. Okay, so now we have the resolution down here. So what we can do then is we take the full length and we do full length divided by mesh resolution, which leaves us with 10 divided by 4 this time around. So what is that? 2.5, 2.5, 5, 7.5, 1. And then we need to subdivide it once more to get these points as well. So 0.125, 0.25, 0.375, 0.5. And then we know the distance, or what we want to clamp it to. So that's beautiful. Mesh resolution, yes. So right around, what do we use this one? Should backface cull. Yeah, we want to keep this one, but we want a view vector center VS. View vector. Whatever. We want to do something like this. Float 3 view vector center truncated world space. Is something equal to something. Yo, what's up, Catboy King? So we want to truncate this, and we want to truncate it by float trunc. It's equal to, actually float 2 trunc is equal to float 2 dimension mesh dimension.x divided by mesh resolution.x, but we do a 2 times here, right? Something like that. There we go. Like this. And then we have, so now we have the truncation we want to truncate to. I think, I hate doing truncation over and over, or implement it over and over. I think we have a pretty good implementation here. Truncate float F step. Then we have F2 step. Okay. Yeah, it looks to be all right. Yeah, so step is a way better name here. And then we do view vector center truncate VS is equal to... Now when I think about it, we're gonna do this. Float 3, we're gonna handle Y from the beginning as well. So we do I want to handle Y? Yeah, I think we do. If we position the camera upwards, we might get... We're gonna handle Y, but we're gonna handle it in a little bit of a different way. So we're gonna do... we can start with X and Z, the easy ones. So truncate view vector. No. Truncate. It's view vector center. View vector center VS dot X and step dot X. Then we have the Y here. For now, I'm just gonna set this one to position center VS.Y. Truncate view vector center VS.Z step.Y. View vector, that is not true. It's not the view vector here. We want to take world space camera. View world space camera position. Here. Here. So camera position world space, but camera position truncated world space. Okay, there we go. We are gonna work with this one. I just want to make sure it is correct, so we're gonna calculate it in the fragment shader, and then we're gonna do return inverse lerp float distance is equal to length of input dot position vs minus camera position truncated vs. So we truncate the camera position to be on our grid. We then take the truncated position, the length, to whatever fragment we're rendering, and then we add that distance here, so we lerp it between these bounds, just to be able to render it nice. Let's see if we have any compiler errors. We should be seeing like a spherical or a circle-ish grayscale render on top of our terrain, and it will truncate to its nearest subvertex pretty much. Position center vs, yeah, instead of this one right here, we're gonna do position vs dot y. Come on. So I had hoped. Max height 0.8. Mesh resolution is 444. Mesh dimension. Oh yeah, we changed the size of this one. 10, 10, right. But I don't think that will help us. It's just like we returned this color, isn't it? Black, 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 black. Truncate, we double check this one. F divided by step, round, time multiplied by step. Looks all right to me. Okay, that works. Distance seems to be 0 at all times. What am I missing? Step, mesh dimension, X. Ooh. Now mesh dimension X divided by mesh resolution. Position VS, do we send down position VS? Yeah, we do. There we go. Okay, I wanna do it the other way around. Y, X. Oh no, it was this one that returned the wrong answer. This one was okay. Okay, beautiful. Now we can change this one, make it more... Or no, actually, it was. I want the point in question to be white and everything else to be black. Okay, there we go. And then we lower this one. Visualize it better. We can lower it like this, actually. And then we move to down here, down here. Am I worried about this point being included? I don't think so. No. No. Or... no, I think I want it like that. Okay, so the white dot here is our truncated camera position. It looks to be all right. Beautiful. We can make this one a little bit bigger. Okay, so the idea is if it's located here, we subdivide this one x times, these x minus 1s and these x minus 2. The problem is... Nah, it's not a problem. And then if it's located here, we subdivide these two x, these x minus 1, and these x minus 2. And yeah, it's pretty straightforward. So... let's jump back to this shader. I'm gonna keep this one here, but we fixed one thing, this, right? Z here instead of Y. Very important. We have our tessellation. We have our tessellation right about here. That. Although... I mean... whatever. Okay, so what I want to do now is I want to base this the subdivision amount of number of steps to this position. So let's see. We take the center point here and we measure the distance to this one. We're gonna have to accept some. So the distance from this point to this point is exactly step. But we want to compare with some error because you can't rely on floats. So we take the length from this point to this point, and then we plus some error, I reckon. So we calculate this distance, or no, we take... Is that the easiest way? We calculate this distance and then we divide it by step. So here we would be getting 1. We take the length and add epsilon. And then we divide it by step. So here we would be getting 1. Here we would be getting 1. Here we would be getting 1, 2, 3. So we actually want to divide it by step times 2. So then we don't need the error, do we? We do, probably. So let's see, here it would be 0. This is 1. Okay, we don't need the epsilon if we go with 1. Okay, take the point minus the truncated position, divide by step times 2. So this one will have 0. 0. This one will have 1. We're gonna round it as well. 1, 1, 1, 1, 1, 1, 1, 2. And what do we have here? We have 0.5, 0.5. So, like, do we want to float it? We might need the epsilon. But 1/2, 1/2, 1.5. So 0, 0. Okay. so we want to calculate camera position truncated, and then we do load tessellation how tessellation offset maybe is equal to length of position center vs minus camera position truncated vs. Tessellation offset divided by 2 times step. We can keep this one on this line, I think. Yeah. Tessellation offset, and then what we do here is that we remove this lerp and we do tessellation amount pow. This is the maximum amount of tessellation we do, and we do minus tessellation offset. Maybe. And that works beautifully. Although at this point okay, it works here, but it doesn't work here because we get... How the fuck is this? I thought we had one full length here. This has to be shorter than that. Are we doing the rounding wrong? Maybe. Or not doing any rounding yet. Okay, so it works for everything except this point. Diagonal lines are fucked. Oh, this is beautiful. This is the solution I hoped I would have found first time around. But okay, let's see. It's something that doesn't make... one thing that doesn't make sense to me here. Step is equal to the distance from here to here. And then we multiply step by 2, so it's the distance from here to here. One full subquad length. This diagonal here, if my understanding of Pythagoras, I don't even know how to pronounce it in English, is correct, this one should be less than step times 2. So what the fuck? It has to be rounding then. Yeah, it rounds to 1. We might want to lower whatever we get here. I wonder if that will screw up something else. Beautiful. 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 What happened with the music? There we go. Okay. Next step is I want to subdivide, or I want to remove some subdivision based on the height here as well. So here we will probably subdivide it the most amount of times, or the full amount of times. Here we will minimize it a bit, minimize. So we can do that by doing we're still gonna keep this, but tessellation offset. I'm thinking of having tessellation offset tessellation offset plane. But then we're gonna bring this one down here. The float tessellation offset height. And I think we want to base it on step as well. Yeah, we do. We're gonna do floor, abs, position, center vs, yeah, dot y minus world space camera position dot y. Divided by 0.0 times step, maybe. So position of the plane, world space camera. Okay. So this one we don't use anymore. So we're gonna do tessellation offset equal to tessellation offset plane plus tessellation offset height. And then we do tessellation offset here. Everything else still holds true, right? Yes. Okay. Okay, I reckon we're soon done with the easy part of this. Shit. Or actually, I think we're done with it right now. So now we're gonna move to this. But ignore this one. I'm gonna take this one. We're gonna bring it over here, maybe? Here. Then we bring this one over here. So now we have this, and now we want to add this split, but here, when we go I thinking about this the correct way? Root. Yes. We want to add 2 extra points here, or is it just 2? Yeah, we want to add this point and this point. So down in our geometry shader, pretty much we have these 3 points. We identify which 2 points create the diagonal line. For the pairing of the 2 other points that doesn't, we want to check if the UV, if the tessellation UV is 0 or 1 in either X or Y, then we need to check the neighboring quad's tessellation amount, so we're probably gonna have to recreate it. But I wonder if we can... Okay, so the most straightforward solution would be to just do a lot of branching and stuff like that. Really don't want to do that. We can calculate the direction of... So given our truncated point, or our camera position point, we can calculate the direction for which the tessellation grows. So for instance, then we know if so like if we have our camera positioned here, we can set we can just take our camera position, our center position of this one. We're gonna calculate it in the domain shader. So each vertex here in this one will know the sub-quad's distance to the camera. So what the fuck, that doesn't make... For this one it would be... that doesn't make sense. If we take the truncated position, here it's gonna be 0. If it's positioned here, this one will have a vector downwards, this one here, this one to this. This one would have a vector of 0, 0. I think that's okay. what if it were positioned here? So then this one knows that if we move it towards this one, we don't subdivide more. If we move towards this one, we don't subdivide more. And we don't care about that one. If we move from this one here, we know that we don't subdivide more. This one here. We don't... Or no. If we move from this one to here, we think that we subdivide more here. Okay. Before we continue with this one, I just need to run AFK real quick. So give me a couple of minutes. AFK, let's be right back. 1 sec. Okay, back. Sorry about that. Okay, so this does not work. We want to identify in what direction we subdivide less, pretty much. Because we want to identify where we should add these. I don't want to do the full recalculations for every triangle. That feels... I wonder if we... Like, if we could be able to add some data to the domain shader output. But am I correct in this? Yeah, shouldn't we be able to just... No extra subdivision here, no extra subdivision here. Yeah, we just take the... Oh, that doesn't work. Could probably mark them. We can mark the point easily, I think. We can mark the edge point easily, that is. But... we can work with step here, shouldn't we? So in this case, if we take the distance to the camera, the direction to the truncated camera position, and then we truncate it. Or I don't even think we need to truncate it, we just need to do seal it. So... Or is it floor it? So here we get, let's say that we get minus C minus C, but it's less than one step like this, so we floor it, so we get 0, 0. Here we would get minus C minus K, C, we floor, so that's 0. Or I mean, yeah, C we floor, so that's 0, K becomes 1. So then we know to this step. Okay, I think so. Let's try it out. And I think we want to mark this direction, we want to mark these with that one. But I think we can mark them just with 1s and 0s. Yes, I think we can do this. So up in... It makes me wonder if we want to do it hatch If we want to do it here, might want to sand something in here. We want to call it. Are all of these 4 points gonna have the same? Yeah, we're gonna go from the center point. Yes, we are. Float 2. Decimate direction. Is it the tessellation direction? Yeah. Tessellation direction. And then we calculate this one here. But I wonder if we can use something we already have. Camera position truncated. I think we can do tessellation offset. Output dot tessellation direction is equal to this one we want to use. We're gonna do actually tessellation direction is equal to this one, but here we have x and y to xz dot xz. Or am I... Don't we want exactly this, pretty much? Position center minus this. Yeah, I think we do. But no, we don't want the length. That's about it. Yo, what's up, Spires? Thank you for the raid. Appreciate it. You too, you too. It's this length we don't want to do. So yeah, we need to do it like this. But we can take this one here then. Like this. Problem as I see it, however, is let's do it like this. Let's make it clear for future me what the hell we're doing here. Yo, what's up, Smack GDs? Tessellation direction, position center vs minus this. I want to lower this. Subdivide it by step x, y. Back to this, I thought you were sick of GPU code. Yeah, I am. But I'm stubborn as hell as well, so I'm gonna see this through, and then we're gonna do some gameplay and most likely some UI stuff as well. Probably not next week, but the week after. I want to double check if this tessellation direction is what I think it is. So we have it here, domain shader interpolated point. Let's leave that one for now, but let's do float 2 tessellation direction. Export 2 and so in the domain shader, each patch is the same, so we're just going to do output dot tessellation direction is equal to patch 0 dot tessellation direction. Doesn't look too great, but whatever. So now down in our fragment shader we do have tessellation direction. I wanna print this shit or render it. So let's do return float 4 input tessellation direction 0 1. Yeah. We don't use this one, do we? No. So why can't I domain shader output dot tessellation direction Patch 0. Oh. Now we have it here as well. So what are you complaining about? Implicit truncation. Let's remove those. Ah, interesting. I don't care about this truncation, but this one. What am I not seeing in this case? Invalid subscript tessellation direction. I'm gonna assume it's this one. Okay, it's actually not this one. This one, patch 0. Oh, yeah. Factors dot tessellation direction. Beautiful. Interesting. We're gonna disable this one for now. Okay. Fuck, I would like to be able to render this one as well. So we're gonna do what's up, Viral Air? I want to be able to render both of the actually we're gonna do float A is equal to this one. And then we do return this, not double return, but we do 1 minus A times this one. That works. Although actually, let's just do A plus this one. Don't care that much. There we go. So this one marks that we tessellate more in the positive Z direction. I'm gonna do this as well. tessellation direction, it's between -1 and 1. We want to bring it up to, so multiplied by 0.5 plus 0.5. Does this make any sense? Oh, yeah. To make it a little bit simpler for me, .x 0. Actually, one more thing. Tessellation direction. This one can have a value between -x and x, where x is the number of steps we are away from the center. So rendering it like this, not very good, but we can do inverse lerp, I suppose, -4, 4. And input dot tessellation direction dot x, and we don't need to do this, something like that maybe. Nah. What the hell? I think I should have thought about this way earlier. We're gonna do it like this. A plus dot normalize input dot tessellation direction and float 3 0 0 1. Seriously? So we have a tessellation direction x. Ooh, yeah, it's only xy 0 1. Float 2. And then we do inverse lerp 0, 1, -1 and 1. But then again, so here it's 0. I want to be able to differentiate between these. Okay, what is the best way to render this direction? I think actually I don't care about the amount of it. I just want to do, okay, so normalize. Float direction. Normalize input.tessellation direction. Gives us -1 and 1 times 0.5 plus 0.5. But, and we only do x here. Zero here. This doesn't make any sense. Or actually it might. But we want to invert it as well. So this one has an x value of 1. Where do we have our point, by the way? Okay. Okay. Let's do, so we get the y here when we normalize. I don't want to do that. Instead, we want to do we have sign or direction or something like that in HLSL? Sign. Thank you. Okay, we get -1 if it's equal to 0 as well, but I don't really care about that one. But we can do this. Direction. Direction is equal to 0.5 if sine of this one dot x is less than 0. Now we're gonna have to do if this one is equal to 0, else if and let's do one of these, and here we don't do anything. Else if sine of this one is less than 0, direction is equal to 0.0. We can just do else here. Something like that. Okay, beautiful. Yo, what's up, Fabic? Good morning, good morning. Thank you again, Robin, for your help yesterday. No problem at all. Okay, this looks exactly what we want. I think we want to do sine earlier though, but I am a little bit worried about. Okay, what it tells us here is that this one, the direction towards this center here is negative. We need to flip these as well. That's what sucks. Direction. We can do tessellation direction. Do negative here. From this subquad, I mean, if we move in the positive x direction, we arrive at a way more subdivided subquad, so that's good. Same for this. It's not exactly entirely true for this one though. Huh. And this we need to differentiate. Yes, it's not entirely true in all cases. So for this one, yes, we move one step to get to the camera point, but this one is tessellated one less as well. We could do Okay, how do we handle this? How would we handle this one? I think we can calculate 4 different values actually. But I don't like doing that. So for instance, if we take this quad, if we move to the right, do we subdivide? If we move up, do we subdivide? If we move left, do we subdivide? If we move down, do we subdivide? That is going to result in so many extra calculations, although it's in the hull patch constant function, so it might not be that bad. So this one, for instance, if we move here, we don't subdivide, so false. If we move here, we don't subdivide. If we move here, we don't subdivide, we decimate, so it would be false as well, and up here it would be false. For this one, however, we would have false, 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 true. Don't we have a better way of doing this? Maybe that would actually be quite nice. But then again, this point, for instance, could prime this in the vector shader as well, I think. That might actually not be such a bad idea. So when we just have these vectors, for this vector we check located here, we're one away. What I'm getting at is, what if we did these calculations already in the vector shader? Here we take the max, can transform it here. Or what if... Yeah, I think we're just gonna do this. Let's send it down per edge. So instead of tessellation direction here we do float. So I pretty much want to mark an edge as edge of interest or whatever. Extra tessellation. Call it seam. So this one, for instance, if we go I don't like the amount of extra calculations we get from this, but if we jump one step downwards from this one, like where do we end up? Let's do it like this and see what we have. So we calculate the center point here. Want to move one step down. And check if the Z is different. Let's see. Camera position truncated world space. Basically that would be equal to, we take the center position here, we jump one step, and we want to compare the distance to the truncated camera position. If it's bigger than X, yeah, then we don't subdivide. Then we need to handle this as well. If we take this one and jump... Yeah, it's basically this. If we take this one, jump one step downwards, are we further away from the truncated camera point? If so, mark it. But it just feels like a overcomplicated way of doing it. I think. So it's basically calculating, or calculating 4 different positions, doing this comparison again. It's to be an easier way, cleaner way. I mean, we could do it like this. Let's do it the dirty way and see if we get it correct. So basically, it was up down, no, Chris. Somehow for me it always reminds me of quad trees. This is basically a quad tree. So we basically just have one big quad and then we split it when we're closer to it. Dirty way is the best way to test, yeah. So like, we're gonna do the dirty implementation, but initially it's just a quad like this. We have decided to create it on the CPU with a subdivision of 2, so we get 5 vertices on each edge. And then as we zoom closer, it's this quad tree-like subdivision. But okay, let's do it the dirty way. So I want to get tessellation offset plane. So float, calculate tessellation offset plane. We send in a position, position, world space, and we send in camera position truncated in world space. And turn this just tiny bit too long. We shouldn't have changed anything, but we need to send in step as well. And then we need to send in step here. Okay. We just do exactly the same thing, basically. So what I want to do here then is output.seam 0 is equal to, and then we have to go back to this one. So edge 0 is downwards. So we're gonna do calculate tessellation offset plane. We're gonna do position center vs minus float. Is it a float 3? 0, 0, and here we want to move 2 times step. Camera position truncated and step. We're not done here, but do you have class name? Tessellator sounds epic. Or kinky. The idea is that when we have this tessellation in place, it's going to be used on a lot of different shaders. We can't really work with classes in the same way, but we're probably going to have a util tessellator. So a shader file we can include whenever we want to tessellate. But okay, seam 0, we move down in Z. But we're not done there. I just want seam to be either a 0 or 1. Incorrect number of arguments. Float 3. Which one are we talking about? Did I forget to... Yeah, float text chord. And we currently return... I will return a float. I'm going to tessellate you. Sounds like a threat. Sounds like a threat, but I mean, guess I see getting tessellated as something good. Okay, so what am I missing here? Output seam 0. Calculate tessellation offset plane position. Float 3 minus float 3. Step is a float 2, so we want to do step.y here. Okay, there we go. I want this as a binary value. We want this to be 1 or 0. We want it to be 1. So if we're in this one, we go down to this one, and this one gets a bigger. If this function returns a bigger value than we did here, then it's a 1. No. If we move down, it gets a smaller value. So it's basically, we're at this one, we jump down and check. We get a smaller value returned here. Then we want it to be true. So yeah, if whatever we return here is smaller, than tessellation offset plane, then we return. So this one becomes 1. Okay. Copy all of this. One, two, three. So seam 1 is this one right here. Then we want to go 0.0, and we want to go negative step. Let's do it like this. The X direction. Oh fuck, it's this one we want. There we go, and then we have seam 2 that's up. So actually we want negative here, positive here, and positive here, I reckon. Okay. Okay, and then what we're gonna do, now we have these seam values. Then I want to do this. We're gonna add, so we have seam in domain shader output. We're gonna have float seam, just a single float. So in the domain shader here, we're actually gonna do float seam is equal to interpolate by linear. Now let's just copy all of this. UV tessellation. And how do we want to do this? Oh, fuck, now we're interpolating seams again. I hate this. So if we're at a point here, for the X we want to interpolate between these two, for the Y we want to interpolate between these two. It's actually like we have it's more like a diamond than a quad this time around. Actually, do we want it as a... Do we want it as a two-dimensional... No. It's pretty much like this. If we have a point on this edge and this edge is has a seam that is 1, then we want to make this point have a seam of 1. So the best way would be to we take the max, I think we're gonna do. So we interpolate E1, E3, and then we interpolate E0, E2, and then we take the max of the result. And if that one is if it's equal to 0, okay, so we do seam is equal to max of lerp we're gonna do UV tessellation here, so E0, E2, so that's factors dot seam 0 factors dot seam 2 UV tessellation X seam 1 3 UV tessellation Y. Then we take the max of those and we check if this one is equal to 1.0, I guess. And then we can do output.seam is equal to seam. We don't really need to create this individual like this, but we'll get to it soon. So we output seam here, then in our fragment shader, let's try and do return input.seam. Let's see what we have. No. Or no. I like what we're seeing here, but I would like to see it the other way. I don't care too much about... We can do it for those as well. Did I forget to... Seam 0 and 2, 0, 2, X, 1 and 3, Y. seam 0 is negative in Y here. That's world. H2 is positive. Okay, let's try and just return this then. Okay, I like what we're seeing here. Although I would like to have it inverted. We have a seam if we jump downwards. If it's tessellated more times, we don't have a seam. Yeah, so if it's like this, we want to do it. No, it's not. But it looks to think about this one. So if yeah, tessellation offset plane, if this one is smaller, we tessellate more times. So this is true. So like if whatever we return here is smaller than this one, then yes, the neighbor is tessellated more times. So I'm missing something here. I think so. Probably. We just return seam. Okay, let's just do seam is equal to... The hell, we're getting the correct values, but they are... But it doesn't make any sense to flip these, does it? We're getting one here as well, that's not good. Like, this is what I would like to see here. This one, this edge is 0. Or this edge is 1, this edge is 1, but why the hell is this one? We move up, it becomes bigger. We move up, it becomes bigger. I'm missing here. Calculate tessellation offset plane. What we do with offset plane later on is we pretty much subtract it here. So that means if this one, if we move down to the other quad, and these calculations for that quad returns one sec. Yeah, what the hell we do? Yeah, we take Y into account here when we shouldn't. Right? Yeah, we do length and position vs. Okay, so basically when we move down in the Y direction, we're only interested in, but fuck, shouldn't this? No, this should work. So we're here. We move down to here, calculate the tessellation stuff. This one is tessellated more times, i.e. what we return from here is smaller than this one. So this seam should be 1. Oh, I see. Double negatives. There we go. And what if we add back this? Beautiful. And then what if we add back beautiful. Beautiful. So all the vertices that are marked as white right here are vertices or edges, or yeah, later on in the geometry shader we're going to go through all edges, and if both vertices are marked as seams, then we want to subdivide them once more. Okay, so this is beautiful. This is absolutely beautiful. Okay. Now I think we're ready for the hardest part here. Because now we're gonna do this. But if these two... Actually, let's copy this one. Oh, no. Let's do it like this. I'm gonna zoom in a bit, so we're gonna do... not that much. I'm gonna recreate one here. I need to move this one more step. Okay, so basically, in a normally, we do subdivide this. Subdivide this. Subdivide. Subdivide this. And then we subdivide this. Subdivide this. And we subdivide. I don't know if this is... Where do we have center here? Looks a little bit off. This one is located over this one, and this one is located there. Okay, something like this. like this, I think. I want to add some naming and stuff here as well, because it's gonna be extremely important that we do this right. Worst case scenario, we will get one that is subdivided here and here. So basically what we're gonna do is we are gonna add fuck it, is it this point? Come on. And this point. We might also add these points here. Okay, so this is going to be a little bit complicado. But let's see here. I want to name these as well. So what do we have? We have 000102. Let's see here. And we always name them as, I think, always 012. Yeah. So where do we have text? Here we have it. Is that a little bit small? Maybe it is. 54. This is 00. O1. O2. Then we have S01, S12, and S20. 20, I mean. This is one S12. S01. And S. Do we name? Nah, we name it 20, don't we? Yeah, we do. And then we have S1201, I think. I want to position it. S1202, right? And S1200. It's very important that these are correct, because what we do then is we create triangle strips from this. So we can see here that we create a triangle strip from S01, S12, 0, 00, S20. So S01, we start with this one, then we go to this one, then we go to this one, and then we go to this one. So that's this one. So we're gonna have to add 2 if statements during this triangulation. If this one exists and if this one exists. I wonder if we can do we're gonna have to split it there, I think. So if this one exists, we need to split it into one more triangle strip, or do we? I don't, maybe not. So we're pretty much gonna create a triangle strip that is so let's take the first triangle strip. This one. First of all, can I change multiple of these at the same time? That would be amazing. Okay. This is the first triangle strip we create, and we create it like we might need to create this one. Actually, let's do this one, or this one. It should be, we should be able to create this as one triangle strip, shouldn't we? Worried about, no. Okay, I don't think we can. So worst case scenario, this one is connected to, this one is connected to, yeah, we're always gonna get, this one is always gonna be connected to more than 3 points, right? So here it's connected to 4 points, 4 points, 5 points. So we're gonna have to split this into 2 different triangle strips. That fucking sucks. Unless I'm misunderstanding something. It's gonna be related to this to do, so we will fix that later on. So it's basically, if we find this one to be split, we're gonna have to split the triangle strip, and then we need to do something similar here as well. So right now we do it as three triangle strips, I think. We have this first one, and then we have one here, and then we have one here. So the other ones are gonna be a little bit easier to fix, I'm pretty sure. Okay, I wanna... Can we scale all of this? Oh, and then we have two front, two back. That's good. Okay, let's do it like this, actually. We position it here. Orange triangle straight. Then we take the next one, which is equal to... The good thing with this one is that it can only be split in one. Oh, that's very good. This one can only be split in one way, and we have the same with this one. And I want to make it look a tiny bit prettier, so we should do it like that. Whatever. And the good thing with this one as well is that it can only be split here. But both of these splits are gonna split these triangle strips into 2 triangle strips because we get a point. This one is connected to 4, and we can't have that. Yeah. Okay. Worst case scenario, we get... Oh no, did I? Worst case scenario, we get... What is it? Brief. Originally we have 3 triangle strips. Worst case scenario we get 2, 2, 2, 6 triangle strips, so we duplicate it. Yeah. I want to use green here. Yeah. So this is what we're looking at. Although I wonder, it's very nice. We're gonna have to do a double branching here. This one is easy to fix, I reckon. And this one as well. This one. And I think that's the one we start with. So this one. One sec we have to take into account as well. So previously, worst case scenario, we get 3 points in here and we return 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, then we have a split. So worst case, we return 1, 2, 3, 4, 5, 5, 10, 14 vertices. If we split them even more times, we return 4, 4, that's 8. 12, 16. Did we have 8? Eight, 24. We actually go from 14 to 24. That feels not good at all. There has to be a better way to split it into triangle strips. We have some constraint here. 24 shouldn't be... 24 should be pretty okay. Okay, let's just solve them like this and see what kind of result we get. What kind of performance? 24 worst case scenario. We create all new points. That's fine and dandy. The first if statement is for this one. So when we create this one, we need to check something. We should be going... So if we notice that we need this one, then we should be going... And if we have already split it like that, we don't need to split. We might as well split them. We might as well split these from the get-go. So what the hell, let's do, originally would have S01 12 00, right? So these two, and then the second one would be the second one would be second one would be this. Just want to see if we have some error here. So what if we do one? It looks all right. So basically we just want to add an if statement here and here, right? So if S01 and O2 or O0, if any of these 2 points are marked as seam, I think now both needs to be it. Because this one can be marked as seam, but we only have downwards. So both of them needs to be it. So S01. So we need to calculate this here. Seam. And when we create these points, we interpolate them. So let's see. But we don't do it for this one. We don't do it for this. Yeah, we do it for this one. S01. We create it here. 0001 UV step. Create point from. So interpolated point dot seam. When we create this one, we care if 01 and 00, both of them are seams. So P1.seam and P2.seam. And for the final point, we just do seam is equal to interpolated point dot seam. We have any seams left? Yeah, we do. But we don't get a seam here. It's interesting. This one doesn't... This one doesn't seem to get the seam memo. Interpolate this point from this one and this one. Both of those two are marked as seams, right? But this one, did I do something wrong here? P1 seam and P2 seam. Okay. What world doesn't this work? Wait, do we actually care? Yeah, we do. S2O. Grade point from 01, 0001. If both of them are seams. What am I missing? Fuck. No. The main shader. We send down seam. Final point, seam, domain shader output. But if I set these to 100, mark them all as seams. Why aren't our newly created points marked as seams? This makes absolutely no sense. Lerp domain shader output, fuck. Output dot seam is equal to lerp. Good. P1.seam and P2.seam. Interpolated point.seam. Nice, nice, nice. Okay. So we want to tessellate this one first one. So if what is it? If O1 and O2, no. If SO1 and O2, I wonder where we want to add it. So we go like da da da, but we might want to go da da da. So after we have added this one, we want to do if SO1.seam and 1200.seam output stream. Actually, we want to create a new point here. Not a very big fan of these, but I think this is the only way. Output stream dot append create point from SO0 S1200 UV step UV step. Then we append that, and I think we want to do the same thing here. So da 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 da. Oh, ooh, S01, yeah. So if O0 and this one, both of them are seams, we do this. We create it from O0 and that one. Okay, let's see how this looks. Where can it... Somewhere we should have... Did I screw up somewhere? Yeah, it doesn't look like we get a new point. What the hell? Where did I go wrong? Okay, here we split them differently. Okay, but then we should be seeing it here at least. But we don't. This one right here. Oh, did I fuck up? Hell yeah, I did. What the fuck? But we did this in a very... Parallel, what's up? Oh, what did I come back to? Yeah, chaos. SO1 SO1 1200 00. Are we Then we should be adding a point here. But okay, this doesn't work. Why not? UV step, UV scale. That should be okay. Don't we want to triangulate this one like this? Da, da, da. One of these triangles should be split. So if we check this one, we split it like this. This lower one right here. This one. Should be seeing a split here. Why the fuck aren't we? Maybe because I screwed up the second one later on. I hope I did. So here we want to go. So we split this first one and then the second one. 00 is 1201. 0 I mean. If we have a seam, we do this. It's just this one we should have here. Okay. Okay. Let's see here. S01. I wonder if our U is the... How did I manage to screw this up? Do we need to go... Let's see, can we bring this one down? Yes. Seams here are wrong as well. We're gonna have to double check that. We have X, Z. Now we do... Fuck it, let's do it like this. Here we have something at least. So we take this triangle, that's exactly as how we have it in our drawings. We split this one by adding 3 new points, and 3 new points here. So it's these two that we try and draw now. Let's see, I want to do... So it's these two. This one we see how its seam is marked, so we should be getting... And then if we remove the first one, it's going to be this one, I hope. So now we only have this one left. We don't add anything, do we? Do we have any difference if we do this? Then we don't get a triangle, and then we set this one here. Okay, interesting. We never do this. Okay. Why don't we? O0 seam and this seam. 12O0 we created from S12 and O0. Seam. Seam. Yo, what's up, Ling Ling? So this doesn't execute because this one hasn't seam. It's 12O0, but we can see here S12O0, that's this one, and its seam is true. Do we get a floating point error? I want to see what happens if this is or true. Or let's just do okay. Yes. It's between O0 and S20. Isn't it? Oh, beautiful. What a beautiful sight. And it's the same problem here. How's life going? How's tessellation tessellating? It has started to tessellate very good. So if tessellation is going good, my life is going good. How about you? So S... Did I really screw it up that bad? Yeah, it's here we want. S0102, so S01, no, 00. Something like this. Oh. Probably gonna turn out that this performance is shit. But look at this. But this is probably, yes, it's okay. We don't handle that one just yet, so that's okay. Look at this. Oh my god. Okay. Okay, we have two more to solve. We have this one to solve, and we have this one to solve. So, how are we walking here? We're walking Da, 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 I think. Let's double check it. 01, 01, S2, 01, S12. Oh, yes, so we go. Now we might need to go. And if that happens, we're done. And then, okay. So I think we can do 00 S2. So here we do if 01.seam and S01.seam. 01.seam and S01 seam. Then we want to do something. If that's true, we want to create this point and restart a strip. So we're going to do, here we're going to do it like this. Domain, shader output, S01 01 is equal to create point from 01 S01 UV step. Now we do output stream dot append S01 01. And then we do output stream dot restart strip. So if we create dit, we restart strip, then we want to do this, and then we just want to continue as we did. So we append it again and continue. It's a little bit of a nice... fuck. It's a little bit nice, but it doesn't work. I realized yesterday that I was using a whole game library in Java that uploads the project massively. Oh yeah. Been there. I rarely use I'm very afraid of using third-party libraries, especially. Brings a bit too much bloat sometimes. Okay, so what did I do wrong here? Why doesn't this work? So let's see. We do 01 S12 01, and then we check if this one and this one are both seams, then we need to add this one. 0101, so this one. So then we go done, done, done. And after we have appended that, we restart the strip. And then we append this again. And then this one. Yeah, we need to append this again. Fuck. What's the difference of walking? Oh, that should work, shouldn't it? Or does this mean that we need to walk? Yeah, maybe we should split it. here instead. Okay, this split might not work. Version issues, that's another thing. Holy shit. And we can probably build this a bit more down here. Okay. Okay, let's do it like this then. SO1. S0101. One sec. Yeah. S0101. And then S01 again. Output stream, not append. Did I say S01? See what this gives us. Yeah, then we solve this, but we still don't have this one. So we don't have this one, is it? So dish. No. Gonna do it like this. Start strip. S0112. S01, that's not the one. Yeah, that's the one we want to start with. S12. No. We want to start with S1201. S1201, S01, S12, S120, okay. The only problem we have now is I wonder if we can do it like this. That looks to be pretty damn good. Start strip. Okay, so then we want to do something similar here. So I guess that's... we create these two. We do an if statement. Let's see here. So for this one, how did we walk? We did S12O, S12O 0. So this one, S20. Yeah, it's here. So we go another direction. We do S1200 up to this, down to S12, then down to... This is where we want to start checking, I think. We can do this one first. Then we do a check. So the check should be located 1200. I think so. Then we get dun dun dun. And then we do the check. If we have a check, we create a new point between S20 and O2. S20 O2. S20 O2. So if we have that point, then we need to do... we do restart strip here. And we add S20. Then we add S1202. This sucks. Nah, it doesn't. S1202, then we add a new point. S2002, and then we add this one. And there we have it. So we can see the splits here and here and here. We can see them here as well. Okay, that looks pretty nice. That looks very nice. Very Larry, it's always better to make your own stuff if you got the time and knowledge. Yeah, I agree with that one, but I also noticed this one. That sucks. The fuck is this? Okay, so at one point we do a split when we shouldn't. Yes, because we check O. We want to check S20 and O2. S20 O2. That should be it. Good luck on the meeting, Ling Ling. Okay. So, I think we got it. Now I want to put it to the... Or actually, I saw one thing that worried me previously. But that might have been... Yeah, this one. What the fuck is going on here? Why do we have a seam here? Okay, we have seams when we move. Sometimes when we move too far away, we have seams that shouldn't be seams. But I think that's quite an easy fix. What I want to check first of all is now that we have a very good solution in place that works. I want to check the performance of it, because this, I'm a bit scared. This is chaos. So let's take camera node, main camera, disable camera controller, and then we can zoom in here. Main camera, align with view, game. Around 260, I would say, compared to yeah, this I don't believe one bit. I am a little bit worried. I would love to do camera controller if we do followed object quad. The I don't think it's too bad. I think I can rely on this solution. We roughly get the same result as if we didn't do the geometry shader, which I find a little bit weird, but I think I want to go with this one because this topology fucking rules. Although I haven't checked, let's see here. Okay, if we do this and we do in the fragment shader, let's just return float for 0, 0, 0, 1. And if we pan around, I don't know how visible it is on stream. Let me see. If I pause here, we still, like in this solution, we have the rasterizer issue. But then if we split it and pan around, we don't anymore. Because this time around, at every seam, we at every seam we match the number of... In fact, this looks weird. Oh no. Okay, we're not fully done. What the hell is this? Why didn't I see this previously? Have I... Oh yeah. I think I... Seriously? Okay, we don't have the rasterization issue anymore though. What the hell is this? We miss one split. Did I forget to... Yeah, this wasn't visible previously. I must have changed something by mistake. But what? So it's one last step. Okay, it's here. We don't do... It's here. Yeah, they are driving me crazy as well. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. It's when we do this one, S12. S12. I think it's when we go this one, S01. S12. Or actually it's... Yeah. When we go here, S1201. You know what? We're gonna fix this one first thing tomorrow because I gotta run. Fuck, I can swear we had it working just now. I must have removed some line or commented something out. We'll fix it tomorrow. The performance was okay. So then we're gonna offset it by height, double check so that works, and then we're gonna apply it to first our snow solution and then our terrain. And then we can move on to brighter futures. Feels great. I love this solution. It's pretty straightforward and clean and easy until it's in the geometry shader. We have a little bit of a chaos, but it's not too much. So yeah, thank you so much for watching, everybody. I appreciate it, and have a great rest of the day. Peace.